So our FinPower Connect web services, we have a very limited number of built-in web services, and more typically, anyone using the web services will be writing custom web services which take the form of scripts in FinPower Connect. So as with the majority of other scripts, these are set up obviously via admin and scripts menu. And they have a type of web service or web API. First distinction to make between web services scripts and other scripts is in the code. By default, if a web service name is not specified, then the web service, when it is called, will be called using the script ID. Therefore, as it's being called over the internet, we don't like things like dots and things appearing in the script ID. So as a matter of course, we would typically not include a dot in the script ID. That said, most web service scripts, if we look at our web page, should override this field here called service name. So by default, obviously our script ID, as you can see here in the tooltip, is WS-Train1. WS-Train1 doesn't mean anything particularly meaningful to anybody that's calling this API externally. So we would typically give this a service name that is more appropriate for the script or the data that it's returning or accepting. So for instance, get account basic, get client basic, those are the sorts of things that we would typically update into our service name field, and that would then be the friendly name, if you like, that anyone using the API would call, as opposed to WS-Train1, which doesn't really mean anything to anybody. As you can see here, as well as the service name under our web options, we also have things like include debug HTTP headers. So by default, because the web service scripts initialize their own business layer, writing finbl.debug print, you won't see that in any session of FinPower Connect that you're running. That'll run under the business layer that's being initialized via the web services. Including debug HTTP headers means that we can actually write that debug out into the response that is given from the web service call itself, and we'll go through a demonstration of that shortly. As well as that, we can define which web roles are available to use for this particular web service. And obviously there are 3 different types of authentication options for FinPower Connect web services. You can connect as a client, as a user, or as a web admin. Typically, web admin should only ever be used for testing purposes because it overrides the things like the web subscriber records and things that are needed to authenticate properly. So all of your web service scripts should be running either as a client or a user or both. Lastly, we have the option to allow anonymous access, which allows completely unauthenticated access to the web service script. That is obviously a very dangerous thing to be switching on, and you should be absolutely sure that you need to do that before checking that option on. As I say, it requires anyone can call that web service basically across the internet. So there are use cases for that, but most typically that should remain off. And it's a good thing to double check before you go sending any scripts out. Okay. Testing our custom web service scripts can be done in a variety of different ways. The most common and easiest way to test them is using our built-in test web services form. So you can see here off of the tools menu, we have the web options, and one of those is test web services. We fire that open. All we need to do is ping in the web services URL. In this case, is installed locally on my laptop. We specify a request format that's either going to be JSON or XML, and then we specify who we're going to connect to the web services as. And this can be, as I said earlier, typically either a client, user, or a web administrator. We can go ahead and as a user. As a user, we have to add a subscriber and secret key. By default, in every demo database, there'll be a demo one there for you. But most typically, again, anyone that's writing custom web service scripts to be consumed by any kind of third party should define a proper subscriber record. Go ahead and pass in our FinPower Connect user and password and sign in. And there we go. We successfully connected as a user. Underneath the Web Services tab, we then have all of the built-in web services, including our custom web services, which is obviously what we're looking at today. To test a custom web service, you're either going to be executing a GET or a POST request. Obviously, a GET is returning data and a POST is posting data. So you can think of returning client records as a GET, saving a new client record would be a POST. And a GET, we can specify our script D, which is the WS train 1, and we can hit the test button, and there we go. We can see that we've successfully called our web service script. We can see here that this is the entire HTTP response that's returned from our web service. You can see here that the data we're returning is simply a string of text, and our request details go through the following URL. That's the URL to our web services, plus the custom handler, and then our web service ID. Now, obviously, if we had updated our service name field, then that would be what appears in here instead of our script ID. And as I say, best practice would be to give your web service scripts a meaningful service name, because this is the URL that will be called by a third party. Much nicer to look at. It also then gives us the authorization header that was used. We won't go through authentication and stuff today, but we will do in a future session. So in a nutshell, that's how we configure and run and test a custom web service script. We look at our script code. First thing to note, I've pasted in the default template code for the web service API, web API script type. First things to notice with our script code is that obviously main doesn't return a Boolean and instead returns a FinWS HTTP response, which basically means it's something that the internet can use. It accepts as a parameter our request, which is a HTTP request, which contains all of the details of the request that was made to the web service. So any parameters that were passed to the web service as URL parameters, or any post data that was posted to it will be available using that request object. Next things to note is we can do some additional user validation. So you remember back on the web page, we can define which web roles can access this web service. We can also then do some further validation inside the script code itself. Assuming the user has validated OK, then we will typically go and do stuff in here, and then we'll finally return a response. And the response is obviously what gets sent back to the person who's made the request. So first thing to note would be debug. So obviously I alluded earlier to the fact that we can include debug HTTP headers. In order to debug FinPower Connect web service scripts, exactly the same as any other script. We can simply write debug print lines, and they will appear as long as you have that option switched on. We come into our test web services form. You'll see that these appear in your response headers. Okay, so you can see underneath the WS user, you can see here debug 1, debug 2. These will appear in order underneath those. So it is possible to debug the scripts. It's not particularly easy. Other options for debugging include writing things like a user log or an account log if you're dealing with a specific account. Just remember that any of that kind of testing code obviously needs to be removed before you send the script out. Other things you can do is to copy the contents of the script code into a general script and remove references to HTTP status codes, etc. and run your script code up from a general script and have all the usual debug options available to you in FinPack. So the choice is yours, but like I say, debug print with that option switched on allows you to at least see stuff in your response headers. Again, really important just to make sure that you remove those debug lines if you do that, because obviously it's going to be potentially confusing for anybody that's calling the web service to be getting a whole bunch of junk back in their response headers. Okay, parameters that are passed through to the web service. So obviously, as a web service call is made, we may well accept custom web service may well accept any number of URL parameters to be passed along with it. So you might find that something like a get account basic, that's an account ID. If you look at the request that was made to the web services there, you can see here that this is the URL that was called. Then the account handler, get account basic, and then a parameter. Parameter is obviously the account ID that we passed in here. We do the same thing with a custom web service, and you don't have to define those parameters anywhere. It is quite useful to do so. So even though the parameters page as such, the parameters that are defined on here don't actually get passed through to the script code, it is useful to anybody that comes to work on the script in future to know that that the web service script is set up to accept some parameters, and they are listed and are listed here. To interrogate those parameters, we can use our request, do an if OK check first. Our request, which gets passed into the main function at the top and contains all of our request information, has request.parameters, and that's an IS key value list in exactly the same way as parameters or script constants would be normally. And therefore you can access them in exactly the same way. Get string with a key. Okay, that'll obviously then return your request parameters. So it's exactly what this get account basic one is doing here. It's accepting a parameter of account ID, and inside the script we'll be doing something with that. Okay, so parameters literally just sit off of the request itself. So off of the request itself is any data that's posted to it. So as I say, if you're making a post call, so for instance, you are passing across some client information, you're going to save a client in FinPower Connect, then you might be passing across a rather large payload. You may be passing across things like the client's name, date of birth, addresses, phone numbers, all that kind of stuff. So all that will very quickly blow out your URL if you were to be trying to pass those as URL parameters. So typically you pass those, or they will be passed to you as post data instead. So off of our request object, you can see here we have request text, and that request text will be in either XML or JSON format, depending on how the web services were called. If it was called requesting JSON, then obviously that will be in JSON, otherwise it'll be in XML. Okay, these typically you'll know that because you'll be working with the third party and know what they're going to be sending you and what you should be returning. Once you have that request text, big lump of JSON, and then it'll just be a case of either of deserializing the JSON or the XML, and obviously underneath our FinBR.runtime web utilities, we have the ability to deserialize that JSON or XML string to a little object. And again, we'll go through some of these things in examples, and we'll cover off further in future sessions. So that's parameters. Anything passed through to the web services, be it parameters or post data, all sits off of the request itself. We can then deserialize that if it's been passed to us as JSON or XML using the web utilities. And I guess finally, we can then go ahead. You'll be typically going ahead and doing something with that data, and then you'll be returning a response. That response you can see here, a simple text response called our custom web service earlier. here, that's what was passed back. So we just do a check if okay, then we'll just create a response. Now, we can define that to be a response of a specific type, or we can just use the generic create response. I'd encourage you to probably use the generic create response object wherever possible. That will always return the response in the content type that was requested. Okay, so again, if the request was made in JSON, it'll return JSON. Otherwise, it'll return XML. And you don't need to do any kind of serialization to make that work. So you can pass back a little object, and it will automatically serialize it to either JSON or XML automatically. As well as your response, obviously, if OK has failed, we can create an error response. And again, this is typically just set on the template text. You don't have to have just create response. You can be much more specific. You can return a JSON response, a text response, an HTML response, PDF response. There's all sorts of very specific responses that you can return. Otherwise, as I say, create response will figure it out and serialize stuff back for you. Things like sending back PDFs and HTML can be quite useful to use these specific methods here. Now, we do have a web services, custom web services programming guide, and that is available from the website under our developer downloads. And that has code samples for each of the different response types, or at least a decent explanation as to exactly how they're used. So I'd certainly encourage anybody looking to do any custom web service scripting, or even if you've done some in the past and just want a refresher, go ahead and download that document and have a look through. Particularly in the response section, is really, really useful to know and have an understanding of those different response types. We will obviously add a link to the document on the video that gets uploaded to YouTube. Okay, so if we go ahead and look at a complete sample, see here we've added a service script one I made a little bit earlier. You can see here this one accepts a parameter of account ID, and this is basically a replication of our get account basic web service. We accept an account ID parameter, we do some validation on that, we use that account ID to then load the account. Again, we're setting things like our error code to be a meaningful HTTP error code. If it were to fail, we do some further validation to see if it was a client that's authenticated or an account that's been authenticated, and then we basically go ahead and create a return response object, which is a type of account details, which you can see here is a FinWS account details basic, which is just a little object here that has a bunch of fields that we're going to return from our web service. Very simple overloaded constructor that accepts a fin account that we just loaded earlier and populates the fields of the object using the accounts fields. We can go ahead and call this. Here we know that it has a parameter, and that parameter was our account ID. Test. You'll see here that that's returned all of the fields that we set in our class, and it's already default serialized that to JSON because we made our request in JSON, and we simply used our create response object to pass our little object back. This sample here is available via our code snippets. So if you go into our code snippets and go to web services, you can see here we do have a few snippets available. We have a get basic account details rather, which is an entire web service script. It's in fact this exact script here, as well as a get basic client details script that you can see here as well. We also have then some further scripts which demonstrate making database queries using SQL security filters and all sorts of things in there as well. So again, as well as downloading the programming guide for the web services, I'd certainly encourage you to have a work through those web service samples there, have a play around with them. As I say, you can test any changes you make using the test web services form and just using our custom custom options here. Obviously, that's a very, very brief overview of web service scripting. We will likely do at least one follow-up session to this, as well as looking at web services installations and obviously authentication options and setting up the web services, etc. in IIS. So there'll be sessions on each of those in the coming weeks.